Hello and good evening everyone. Hi, how are you? Happy Children's Day to everyone. मेरे प्यारे प्यारे बच्चों को very happy Children's Day. Triangles lecture number third, all about class 10 board exams, PYQ series, third lecture है. Please make sure to note everything in your notebooks. Hello, hi, good evening, good evening, good evening. Am I clearly audible and visible? Hi, hello, anyone in the comments? Am I clearly audible and visible? All is well in the comments? All is well in the comments fast. All is well. I think all is well. So we can start the lecture right now. This is the PYQ session. PYQ series for class 10th maths chapter triangles, chapter number 6 it is. Okay. So let's start the lecture without any delay. Without any delay. Wait. Wait. Okay. So last we did, I guess, this question number 11th. Okay. In the given figure, E is the point on the side CB produced of an isosceles triangle ABC with AB equals to AC. If AD perpendicular BC and EF perpendicular AC, then prove that triangle ABD is similar to triangle ECF. We have done this question. Okay. Okay. So we'll move forward to solve again a good question. This was homework, I guess. Anyone tried? Anyone of you must have tried. So tell me. So tell me in the comment section. Okay. Question is in the given figure. CD is perpendicular bisector of AB. Okay. So let's solve this one and okay, read this question. In the given figure, CD is the perpendicular bisector of AB. CD. Okay, CD is the perpendicular bisector of AB. AB means BD equals to AD. We have written. Done. EF is perpendicular to CD. EF is perpendicular to CD. Okay. AE intersects CD at G. Okay, at G. Then prove that CF upon CD. We have to find some ratio for CF upon CD. Now, what to do? What to do? Just wait, let me take out the answers. We have to solve some good questions also. We'll be selecting different questions. Not all questions we'll be doing. Okay, so can you see the triangles which are similar in this particular question? Anyone? Okay, let's see. Wait. How to solve? We have to solve CF upon CD. See CF upon CD. Okay. And that's equals to FG upon DG. Okay. First, see these triangles. I write this is parallel to this. Wait. So I can write and prove. Let's start and let's see where we can go. We'll say because EF is parallel to BD. Yes or no? EF is parallel to BD. Both 1990 parallel. So and this angle is common and this angle is obviously 90 degree. Okay. So in triangle EFC and triangle BDC. Okay. We can write these triangles as similar. These triangle as similar. Yes or no? How many of you can see triangle EFC is similar to triangle BDC? Yes, by AA similarity. This angle 1990, this angle common B. So we can write CF upon CD. Okay, CF upon CD equals to FE upon DB, and that's equals to EC or C. Okay, EC upon BC. Yes or no? So CF upon CF upon CD is actually equals to FE upon BD. Okay, done. This question is done now. Now see these two triangles. Triangle EFG, triangle EFG and triangle C. This triangle EFG and triangle ADG and triangle ADG. Are these triangles similar? Yes or no in the comments? We can write this angle is 90. I can make with different colors. This angle is 90. Yes or no? This angle is also 90. Yes or no? Tell me. Okay. Angle EFG, angle EFG equals to angle ADG 90 degree given. Yes. Sir. And what else can I see? Angle EGF. Angle EGF is equals to angle AGD, vertically opposite angle. So triangle EFG is similar. These two triangles EFG is similar to triangle ADG by A similarity criteria. Yes or no? This reasons you have to write. Okay. So what can I write? This ratio EF upon AD. Yeah. So I can write EF upon AD equal to this FG upon DG. Okay. FG upon DG. Now see. Just focus onto the relation which we have to prove. What we have to prove? That CF upon CD is equals to FG upon DG. Okay. Here FG upon DG equals to EF upon AD. But AD is equals to BD. AD is equals to what? BD. Okay. So I will write here. See. So we can write, but last part here. But this AD equals to BD. It is given. Na? This is midpoint. So AD equals to BD. So instead of this AD, I will write BD. Okay. It implies EF upon BD will be equals to FG upon DG. Okay. EF upon BD. See EF upon BD. But EF upon BD. Huh, okay. But this EF upon BD, this EF upon BD is actually equals to what? EF upon BD, CF upon CD. CF upon CD. Proved above? Proved already? So it implies what? If EF upon BD and this is also EF upon BD, we'll write what? CF upon CD is equals to what? This thing FG upon DG. FG upon DG. Hence proved. Yes or no? CF upon CD goes to FG upon DG. Copy. Copy, copy, copy. These are good questions. Okay, we just have to see, focus what actually have to be proved. Copy it. Yes, copy, copy. Copy it and tell me. Done. Done. Okay, let's move ahead. So let's see another question. These are good questions, okay? Uh, in this triangle, okay, isosceles. Easy question. After this, we'll do BPT, okay? After this, we can do BPT. After this, we'll be doing basic proportionality theorem. Okay. What the question says? See, in the given figure, angle D equals to angle E. Okay, angle D equals to angle E. And AD upon DB equals to AE upon EC. Done. Next. Prove that triangle ABC is an isosceles triangle. Okay. Angle D is equals to angle E. It implies what? This side is equals to this side. Yes or no? Because angle D equals to angle E, it implies what? AD equals to AE. Yes or no? AD equals to AE. Yes or no? Hmm? Okay, one thing. So AD upon DB, it is given that AD upon DB is equals to AE upon EC. Just write down what you can write. If these angles are equal, so their opposite sides are also going to be equal. Yes or no? Isosceles triangle. So this we got. Okay. Now AD and AE, because these are equal, so they will cancel out. So cross multiply. So EC is equals to DB. EC is equals to DB. This part is also equals to this part. Now we have to prove what? ABC is an isosceles triangle. That means AB equals to AC. So lower to this you can write A. What is AE? You write AE is equals to AD. It is from here already proved. Add both of these. So EC plus AE is equals to DB plus AD. Tell me what is EC plus AE? EC plus AE. It is AC, and that's equals to what? AB. DB and AD. DB and AD add. AC equals to AB. Hence proved triangle is isosceles. Copy it. Very easy. I think it's not difficult. Okay. Done. Copy it. Then we'll be doing BPT, basic proportionality theorem. Done. Done. Okay, let's go for BPT now. What is basic proportionality theorem? We'll come to know. BPT, you know, you're done in schools. Everyone done in schools. BPT. Huh? Tell me. Okay, state and prove basic proportionality theorem. Here it is. Long answer type questions. One. There's a starting for the difficult one. More difficult one. Okay. Now this is BPT. Read the question first. Hmm. State and prove basic proportionality theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then prove that the other two sides are divided in the same ratio. This we have to prove, right? So let's prove. I'll show you. State and prove. That means you have to write this statement also. The statement. This is the statement for BPT. Statement for what? BPT. Basic proportionality theorem, or you can also see it as Thales theorem. Okay. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then prove that other two sides are divided in the same ratio. That means if a triangle is given like this, see, this triangle ABC, okay. If a line is drawn, so it is given that if it is given that DE, right? It is given that DE is parallel to BC. Given is what? What is given? DE is parallel to BC. What is required to prove? What we have to prove? We have to prove AD upon DB. A line is drawn parallel to one side of a triangle, intersect other two sides at D and E. We have to prove that other two sides are divided in the same ratio. That means this side is divided in AD and DB. So AD upon DB, yes, AD upon DB is equals to what? AD upon DB equals to AE upon EC. This we have to prove. First pre-boards, study for pre-boards, then try for boards. Okay. So we have to prove this is dividing these two sides in the same ratio. So AD upon DB, AD upon DB equals to AE upon EC. Okay. Let me find a good one for this. It will take so much time. So we'll see. Uh, wait. Let me see if I have that colorful presentation now, right now. Let me see that. Till then, you must copy that question for BPT. Not here. We have very good actually presentation for this. I have to show this. Else we'll prove. If not found, then we'll prove it. No, this is also not. No. Proof of BPT. Where is it? Proof of Yeah. Okay. There it but it is not proof now. We had that proof, yes. Already we have. Let me see, else we'll prove. Don't worry. Okay, leave it. We'll prove. Don't worry. Okay. See. So for this, we'll construct. We'll have some construction. Okay. And what will be the construction? See, draw. We have to draw. Draw EF and DG perpendiculars. Draw EF perpendicular to AB and DG perpendicular to AC. Join. Follow these what I have written. EF perpendicular to AB and DG perpendicular to AC and join BE and CD. Join BE and CD. Okay. Join this. Okay, so join this BE and CD. Okay, you have to join these. Now I think everyone can see the diagrams clearly. Yes or no? Okay. Now see, you write area of triangle ADE upon area. Simple, right? Area triangle. Okay, done. Area of triangle. See, when you are writing ADE, another you will write BDE. BDE. So half into base into height upon half into base into height. This will write. So what is base for this triangle ADE? First time we'll take AD as base. So half into AD. I can say EG EF. EF is the perpendicular. Yes or no? Can I say EF is the AD into perpendicular? Half into AD into perpendicular is EF. Okay. Next is half into what is base? For triangle BDE. See, for this triangle BDE, if this is triangle BDE, can I say this is the perpendicular? Say, can I say this is the perpendicular? Yes or no? If I say for triangle BDE, I'll say yes. I will say that half into base is BD and perpendicular is EF. Okay. BD into EF, right? This is extended and perpendicular is like that. Okay. So EF got cancelled. So I get area of triangle ADE upon area of triangle BDE is equals to half also get cancelled. It is AD upon BD, right? This is equation number 1. Equation number 1. Similarly, can I write area of triangle ADE upon area of triangle CDE is equals to what? Half into base into height upon half into base into height. So what is half into base into height now? Tell me. Area of triangle ADE. Now you'll see this triangle ADE. First we have saw this triangle ADE. Now we are seeing like this. So AE will be the base and DG will be the height. So half into AE into DG. Okay. AE into DG. This is half into base into height. Upon area of triangle CDE. If you now can focus, if now you can focus, this is triangle CDE. Okay. And this will be the perpendicular. Yes or no? Tell me. Yes, sir. So I'll write what? I'll write what? I'll write half into for triangle CDE, for triangle CDE. Tell me, Half into base is CE and height is what? Height will be DG. So DG got cancelled, half cancelled. So area of triangle ADE upon area of triangle CDE is equals to what? Area of triangle CDE is equals to what? Simply AE upon CE. This is equation number 2. Clear? Now see, there is an important concept involved in this question. There is an important concept. Now what the concept says? See, the concept says that area of triangles between the same base and on the same parallel are equal. See, what I am trying to say. Uh, let's say this is a line, this is a line. So these two are parallel lines. Yes, sir. And these two triangles, one triangle is this, another triangle is this. These two triangles are on the same base. Yes or no? See, if anyone can see this triangle, this red one, and this triangle, this red one. These triangles are on the same base BC and between the same parallels. So a triangle BDE, area of triangle BDE and area of triangle CDE is going to be equal. Is going to be equal, right? So let's clear this mess. And okay. So we'll say these two areas are equal, the downside, the denominator, right? So we'll write area of triangle, but area triangle BDE is equal to what? Hmm? Is equal to what? Area triangle. This area of triangle BDE is equals to area of triangle CDE. Area of triangle CDE. Why? Because triangles on the same base and between the same parallel lines are equal. Equal means they are equal in area. Okay. So it implies from 1 and 2, from equation 1 and 2, if this upon this is this upon this, same thing. So AD upon BD, AD upon BD is equals to what? AE upon CE. Hence proved. I guess BPT is now super clear. Yes or no? Hence proved. Done. So you must copy this first. You must copy. Wait. Okay. Now it's on the same page. Done. Okay. You must copy this now. Draw diagrams like this. Draw two perpendiculars. Let's clear this. These things if this is because it's disturbing. Okay. Now copy. This reason everyone must write, okay? Triangles on the same base and between the same parallels are equal in area. There is nothing down. It's just AD upon BD equals to AE upon CE. That's it. Nothing is written on the downside. This proof you must memorize by heart. Okay, practice it 2 3 times at least. Done. Done. Okay, let's move forward. So now if it is asked that it's converse of VPT, if they say to prove converse of VPT, converse is very easy. Converse of VPT. See, when it's given, converse is just opposite of this. A triangle is given. Okay, it's A, B, C. A line is this. A line is this. DE. What is given? Given is, now ratio is given. AD upon DB is equals to AE upon EC. What we have to prove? We have to prove the lines is parallel. DE is parallel to BC. Got my point? See this thing. See this thing. What is given and what we have to prove, it will get interchanged. Okay. Yes or no? Here we were given that lines are parallel. Now we have to prove line is parallel. The ratio was about to be proved. Now the ratio is given. AD upon DB equals to AE upon EC. Okay. Now we have to draw a construction. Let, if DE is not parallel to AC, let DF is parallel to, let DF is parallel. We have to prove DE. If DE is not parallel, then some line would be parallel, yes or no? So let DF is parallel to BC. So by proof, now we'll write proof. So by BPT, if this line is parallel to this line, AD upon DB will be equals to what? AF upon FC. AF upon FC. Yes or no? Tell me. Yes, sir. But what is given? This is given that AD upon DB is equals to what? AD upon DB is equals to AE upon EC. It is given. Yes or no? Yes. It implies this is 1, this is 2. So from 1 and 2, AD upon DB, AD upon DB. That means AF upon FC, AF upon FC will be equals to AE upon EC. Yes or no? Yes or no? Yes. So if you add 1 on both sides now see what changes here. Add 1 on both sides. It implies AF upon FC plus 1 is equals to AE upon EC plus 1. We have added 1 on both sides. FC is the LCM. So AF plus FC is equals to EC is the LCM. So AE plus EC into 1 will be EC. Can you see what is AF plus FC? AF plus FC is AC. AE plus EC is also AC. So we'll write AC upon FC. It implies AC upon FC is equals to AC upon EC. AC got cancelled. It implies what? FC equals to EC. How is this possible? FC equals to EC. Tell me. FC equals to EC. How is it possible? Tell me. FC. This part. This part is equal to this smaller part. When? When this F will coincide with this point E. Yes or no? When this F will coincide with E, then only FC will be equals to EC, right? So it implies it is possible only if F coincides with E. So, where I'm going? Wait, we'll write at lower side only, right? It implies so if D DF is parallel to BC, right? DF is parallel to BC, it implies DE also parallel to BC. So if DF parallel to BC, it implies DE is parallel to BC because F and E are nothing but the 1 point. Quite easily done. Hence proved. Copy it. Copy it. This is the converse of BPT. Converse of PPT. I think it's sorted now. Okay. Understood? Yes or no? Tell me. Tell me, got this point? What is converse of BPT? Just opposite of this. And these both can come in exams. 5 marks. 4 marks at least. 5 marks section D, sorry, section D. One BPT and one its application. This is given, this is given, this is given, find this. So this upon this, we can find this one. Right? These type of questions can come as it is. Copy it. If you watch this lecture again and again, if you hit it 2 or 3 times, please both questions. You'll be super perfect. Okay? Don't worry. Don't worry. I'm with you. Don't worry. Copy it. I'm waiting. Copy. Okay. I guess you must have done. If not, then keep on copying. That's it for today. So this was BPT and its converse. right? Keep on copying. That's it. We'll be meeting tomorrow. Good night. And do not forget to solve these questions from this PDF. Do not forget to solve all these questions. Okay, BPT, now this applications of BPT. This question we'll be doing tomorrow. This question is important, can come as it is. And MCQs are super simple. You can try them. Okay. So that's it. Signing off. Good night. Take care. Bye bye.